Hi everyone, my name is Chris Cummings. I am an additive manufacturing technician here at MLC CAD Systems, and I would like to thank everyone for joining us today. I have some exciting Markforged news to share with you. MLC CAD Systems would like to introduce the new Markforged flagship production 3D printer, the FX20. It is bigger, faster, hotter, and smarter. A quick rundown of our agenda today. We're going to start off with a behind-the-scenes look at how Markforged brought the FX20 to life. Then I'll dive into some of the details on the FX20 and the digital forge. We also have Ross Adams, an application engineer from Markforged, joining us today to help walk us through what applications would be a good fit for the FX20, and John Bannon, lead application engineer at Markforged, to help answer some questions during the Q&A section of this presentation. Without further ado, here's a behind-the-scenes look at the FX20.
So we're about to go look at something that no one outside of Markforged has ever seen before. This is top secret.
FX20 is the most ambitious product Markforged has ever taken on. Bigger, faster, hotter, smarter.
We really set out to build the best printer ever for engineers by engineers.
The number one request from our customers has been they want to print larger parts. Going bigger is really hard. When you expand things in X, Y, and Z, you encounter all new challenges. By going faster, you need stronger motors. When you have stronger motors, you need a stiffer motion system. It makes the technical challenge exponentially harder.
The mass goes up, which means controlling the thing becomes more difficult. The FX20 is massive. We made this thing several times larger, and that problem got way more difficult. This is what the printer looks like on the inside. This is an enormous mass that has to move up and down. It needs to be in the exact right place so your part comes out the way that you want it to.
In addition to just going bigger, you really need to go faster, otherwise you're going to be waiting a long time for your parts.
FX20 will allow you to do everything you're used to, but you're going to be able to do so faster, much faster.
With FX20, we're able to go multiples faster without reducing surface quality or finish or accuracy of our parts. And when it comes to hotter, we're enabling FX20 to print Onyx, Onyx FR, Onyx ESD, nylon white, all of our continuous fiber reinforcement materials, carbon fiber, Kevlar, fiberglass, high strength, high temperature fiberglass. Plus it'll print ULTEM 985 filament, which is our first high temperature thermoplastic that allow our customers to address an even wider range of applications that they've never been able to address before.
This is going to allow people who are currently 3D printing parts and putting them into airplanes and really bring those up to the next level.
The high temperature thermoplastics like ULTEM filament are really the top of the polymer pyramid. We're not the first to print ULTEM filament. We're adding continuous fiber reinforcement to it to give it the strength of metal. Totally changes the game. Lastly, Smarter. Our platform, the Digital Forge, continuously gathers data, and we've developed FX20 to capture orders of magnitude more data. Once you have that data, you can use it to control the printer and create ever better parts.
There's optical sensors in there, and based on that, we set the speed of the extruder.
Yeah, buddy. Love it. This printer has more sensors on the print head than all of the sensors on our previous printer combined, capturing all the data that that machine needs to learn, get better, and deliver the perfect part.
This is a printer that's going to continue to get better over time. The day you buy the FX20 is going to be the worst day it ever performs. And it performs really well from day one. So we have a motto here, which is that the part is the product. And that's been central to the development of FX20, from the size of the parts, the speed with which you can print them, the materials that you can print, and ultimately the quality of those parts.
Markforged is known for making real parts, and that's our key differentiator. We bring the function, and form, fit, function, those are like the core things in engineering, and the FX20 is going to take that to the next level.
The surface finish on our parts is better than anyone else's, and there's this tight association between what does the part look like and how high quality of a part it is.
One of the challenges to achieving a really good surface finish is differences in the bed position of the thickness of my hair will show up in the part quality. And we've been through 4 different iterations of this print bed, chasing down that thickness of a hair, and we actually had to reinvent the entire print bed in order to accomplish that. So we redesigned it from the ground up, and we have a much better product now. We're making this bigger, faster, and hotter. We are not making it any less accurate.
One of the defects that we see that are problematic is Z-banding. This is when your system is not mature enough to be able to move the bed at a consistent layer height. It got better. This right part here is a current printer. After we've implemented a lot of hardware and software improvements, and this is the kind of surface quality that we expect to ship with this printer.
The FX20 engineering team is just a dream team of cross-functional engineers that are top of their class in every discipline. So we solve things in a very systems engineering way.
So every time you look at a Markforged part and it looks beautiful, that didn't come for free. That's literally thousands of hours of engineers staring at these parts under a microscope, fine-tuning every detail of the system in order to achieve that piece of quality. And this is the same approach Markforged takes on every printer and every product.
The products we're designing are for people like us. Customers that wanted to rapidly iterate functional prototypes, that want to manufacture products. And what we're doing with FX20 is really taking it to a whole new level. Super excited to see FX20 start shipping to our customers in 2022 so they can build with it and start creating value for them and their customers.
I hope you enjoyed the behind the scenes video of the FX20. Man, that thing is big. I can't wait to get one here in our office to use. All right, let's get down to business. Markforged is on a mission to reinvent manufacturing, and they are doing this by using something they call the Digital Forge. The Digital Forge is their platform consisting of hardware, software, and materials that were designed to work together seamlessly so that engineers can go from design to functional parts with ease. The Digital Forge platform is smart and connected, with software that enables organizations to scale and distribute their additive manufacturing operations and realize the vision of a digital supply chain. Most of you already know what Markforged printers are known for, right? It is their part strength by using CFR, or continuous fiber reinforcement. If you look at the stress strain curves on the right, you can see how the continuous fiber reinforced parts, highlighted in gray, perform compared to typical engineering grade thermoplastics on the bottom, and even compared to 6061 T6 aluminum, with the carbon fiber part sustaining higher stress. Markforged printers are also known for their superb accuracy and reliability. Well, Markforged has done it again with their next generation printer, the FX20. It takes everything Markforged did well on their Mark II and X7, but supersizes it for robust production. It is the biggest, fastest, and most sophisticated 3D printer Markforged has built to date. The FX20 is engineered from the ground up to bring the CFR process to a new realm of parts. The printer delivers improved performance, consistency, and the ability to print high-temperature thermoplastics to unlock the most demanding manufacturing and in-use applications. That's right, I said high temp. Introducing ULTEM 9085. Not only are we introducing a new amazing material, but Markforged made the FX20 much, much bigger, with a build volume nearly 5 times bigger than the X7. The build volume is 525 millimeters by 400 millimeters by 400 millimeters. That's 20.6 inches by 15.7 inches by 15.7 inches. You can print dramatically larger parts or a larger number of smaller parts now, and when printing is complete, part removal is easy with a removable print sheet that is held in place during printing by a precision ground aluminum vacuum bed. If you are an existing Markforged customer who prints exceptionally large parts, you are probably breaking up your large parts into multiple smaller bodies to fit your machine's build volume, and then manually joining and assembling them. Even if reinforced, these parts will never be as strong as a single reinforced end-to-end part. Well, with the FX20, printing that large part in one piece will make it stronger and eliminate the need for assembly, saving you time. Here is an example of a tube bending die printed on an X7 in 4 separate pieces. This job took over 10 days of printing and assembly to have a complete functional part. The FX20 was able to print the same part in just one piece in just over 4 days. That's very impressive and much faster. Alright, let's talk about how much faster. The FX20 is 8 times faster than the default settings on an X7 or Mark II, and it's 2 times faster than the TurboPrint setting on the X7. This significantly reduces print times, but also maintains that print quality and accuracy you are accustomed to from Markforged. Now let's talk about how the FX20 is smarter. Being part of the Digital Forge platform, Markforged leveraged data from the past to predict and shape the future. Their platform benefits from a flywheel effect. Their customers have over 10,000 cloud-connected printers and are frequently adding more. The more printers in the field, the more printing. Did you know every 10 seconds a new part is printed on a Markforged printer? And every print generates metadata that drives insights to make the platform better, which brings improvements to the entire fleet. Extensive system instrumentation fuels performance data that improves the platform, allowing Markforged to push over-the-air updates to improve performance and reliability and enhance the overall user experience. And lastly, the FX20 is hotter. The FX20 is capable of printing at 200 Celsius chamber temperature. For the first time ever, Markforged is printing high-temperature thermoplastics, namely ULTEM 9085, combined with continuous fiber reinforcement. ULTEM 9085 has high heat resistance, chemical resistance, and flame, smoke, toxicity compliance. All these properties enable it to be used in end-use parts in industries like aerospace, defense, transportation, automotive, and oil and gas. ULTEM 9085 is an incredible material on its own, but by reinforcing it with continuous carbon fiber, it unlocks so many more applications than ever before. Speaking of applications, I will now hand it off to Ross Adams from Markforged.
Awesome. We're going to be shifting focus now and focusing a little bit more on the aerospace vertical. My background is in aerospace tool design, and I really feel like aerospace is going to be the largest industry that will have an impact with 3D printing. And I truly feel that Markforged is going to capture that largest market share. So let me tell you why. When we think about aerospace, 3D printing is really in its DNA because of a few core elements. The first thing is the volumes that aerospace works with. Unlike automotive or iPhones or footwear where they're making millions of parts per year, aerospace is a lower to medium volume, talking about like hundreds to thousands of aircrafts per year. And additive manufacturing scales very nicely to those types of volumes, whereas when we start talking about millions, there's a lot more investment that you need to bring the technology in-house versus a lot of low-hanging fruit applications that you can attack when they meet these types of volumes, because 3D printing is going to be slower than some other methods. So you need to find the right sweet spot for applications that you can pursue with it. The second core element is the complexity of their manufacturing processes. So in aerospace, we're trying to optimize for aerodynamic efficiency. So parts are often having smooth contours, and the trade-off there is that the manufacturing processes get more expensive and time-consuming to achieve those contoured components. With additive manufacturing, though, we have the ability to have complexity at a much discounted cost, because as we're adding material, we're not removing it for those smooth contours that might require like 5-axis CNC machining or autoclave molds. And then the third key element is the impact of weight reduction. In aerospace, this is very high because the lighter weight parts that you put in the aircraft, the heavier of payload it can carry, the faster it can fly, and the longer durations it can go. Additive manufacturing inherently is great at lightweighting because we have the ability to add material just where we need it, utilizing honeycomb infills and high performance materials. So these three elements combined together dictate the sweet spot for additive manufacturing. With the introduction of the FX20, we're really expanding the application scope and giving you the tools you need to apply the technology in end-use aerospace applications. So in order to know where we're heading, it helps to know where we came from. And I want to share a story today about the history of the helicopter. So Igor Sikorsky had the vision for the helicopter and brought it to America to make it a reality. When he started building these prototypes, he had a realization that the technologies used to build engines resulted in engines that were too heavy to overcome the laws of physics and create enough lift to allow a helicopter to go into flight. What he was forced to do was actually build fixed-wing aircrafts for over 20 years, keeping a very close eye on the engine technologies. And the second that those technologies caught up and allowed engines to be lightweight and afford the flight of a helicopter, he made this a reality and really changed the course of mankind forever. Sikorsky estimates that over 2 million lives have been saved with the invention of vertical takeoff. And I share this story not because I think that we're going to be 3D printing engines in the future, although we do make metal printers, so I wouldn't discount that. But I share this story because the understanding of where we might be at today with technology and how the limitations of the technologies that we're using today are restricting innovation. As we introduce new technologies, where might we be heading in the future with lightweight designs and the future innovation within the aerospace industry? Let's dig into that. Now I'm going to be levering to one of Markforged customers, SRC. They are become an early adopter for the FX20, but have also been utilizing our industrial series X7 printers for well over a year now for end-use flight-ready parts. They specialize in research and development for radars and electronic warfare systems. They have a very strong reputation in this market. They've been a 3-time winner of the U.S. Army's top 10 inventions since 2004. And their customers include branches of the DoD like the Army, the Air Force, Marines, Navy, Homeland Security, many more. But the common thread here is that these types of branches are always facing new types of challenges and threats within the field. and they come to companies like SRC to invent new solutions to counter those threats and give them enhanced security when they're in combat. Oftentimes when these issues are discovered, they come in the form of a quick reaction program. So there's going to be multiple companies bid in to develop their solutions, and whoever has the best design is going to be awarded the contract. As these companies are bid in, there's three main criteria that they are being evaluated on for who has the best design. First being time to market. So because these threats exist today and a solution was needed yesterday, whoever can develop a solution the fastest has a superior advantage because they can start protecting lives starting now. The second core element is design optimization. And this is kind of a trickier one to put your finger on because there's a lot of different elements that go into optimizing designs. But whoever can create the best solution that does what it needs to do and then has the secondary benefits of being light and reduced form factor have an elevated advantage within this evaluation. Then the third key aspect is cost effectiveness, probably lesser important than 1 and 2. But always important whenever you're designing anything that if you want your solution to scale, it needs to be cost effective enough that companies can adopt it. Now, I'm going to be spending some time and focus on design optimization because unlike time to market and cost effectiveness where we know we're just trying to reduce it, optimizing designs often comes with trade-offs. So you prioritize one advantage and deprioritize a benefit that maybe you can't discover because we need to optimize the design and make it a reality. So what does design optimization look like? SRC's customers use the acronym SWAP compliant. SWAP stands for space, weight, and power. And the goal here is to minimize the amount of space that the part takes up and using design principles and lightweight, high-performance materials to make the part as lightweight as possible. If we reduce the weight and reduce the space, we can maximize the power output coming from the system. And a 3D printer is really a tool to achieve SWAP-compliant designs. Inherently, you can take an assembly that used to be 10 components and make that into a single unified body and reduce the form factor, but also with design principles. So traditionally, you might drill some holes in aluminum to make these lightning holes and make the part less heavy and reduce the stress concentrators in areas that you don't need material. Or also you use high performance materials. And high performance materials, when you look at aircrafts, there's very little plastic goes into them, even less steel. It's mainly composed of aluminum, titanium, and composites. As time has gone on, we've seen an increase in the utilization of composites on structural components. And this is really afforded with the technologies that we have been able to scale out in the world. Right now, we're looking at almost 50% of airframes are made out of composite materials. I think that trend is going to keep going up. But right now, they're limited because composite traditionally are very labor intensive and have a lot of tools that go into that process. You need the molds, you need the clamps, you need an autoclave, you need to do the curing, and then you need secondary tools to do your drilling and your trimming templates around the final part. And for that reason, it's not always cost effective. It doesn't always make sense, and it's going to delay your time to market if you're trying to utilize the lightweight and benefits, but also balance that with bringing a product to market as soon as possible. And this is where we're changing the game, because now we are taking the benefits of these super materials that are true composites, and we're 3D printing them. So this is a toolless process with minimum supervision. We can take a continuous spool of continuous fiber, route that into a precision nozzle, additively manufacture parts, but embedding those fibers continuously into the geometry. And the result is strong and complex parts that come right off the print bed and ready to use inside your aircraft. So we're taking all the tools out of the equation, we're minimizing the supervision and enabling you to utilize these materials and not be prohibited with the traditional methods that block you from using these materials and substitute them instead for like aluminum or titanium. And we have a wide array of fiber materials. We really understand that engineers, always are going to be facing different types of challenges, and you need to tailor the materials you're using to the specific application. So look at these materials, we have stiffness, we have compression, or we have impact resistance. But the fibers are never alone in the material itself. A composite is the combination of two materials working together to achieve a high performance material. And for the first time ever, we are offering ULTEM 9085 filament. And this is going to be a game changer because temperature is one of those elements that comes down to the chemistry of the material. Either it can meet the temperatures or it cannot. It's not like strength where you can just make your features thicker to achieve higher strength. So being able to use these continuous fibers with these order of magnitudes increase in strengths, but combining that with a high temperature resistant material that can withstand temperatures in these extreme environments, you have the confidence as an engineer to send these parts into production and then start having them fly and exploit the benefits that you get from lightweighting and reducing space. So now let's circle back to SRC. And I'm going to be talking about a specific program that they utilize the FX20 for and realize some advantages of this manufacturing process. And overall, that gives them a competitive advantage in their market by achieving higher performance solutions. First up is time to market. So by taking 3D printing and bringing that in-house, they're able to reduce their lead times from months all the way down to days. Not only does that reduce the amount of throughput that you can utilize on a part-to-part basis, but in the design cycle, they can now go through a series of prototypes within the single amount of time that used to take them just to get one part. And how do you optimize your designs? Well, you design them, you manufacture them, you test them, and then you iterate, and you iterate, and you iterate, and you improve. And that's how you arrive at optimized designs. You never really know when it's optimized because at some point you need to put the halt on and start going in production. So the more iterations you can get through, the more confidence you have that you achieved your optimized design. So with the iterations that they went through, they were able to achieve a 15% weight reduction without making any sacrifices to strength. They did this compared to a machined magnesium design that had all these lightning pockets and stuff like that, but instead utilized ULTEM 9085 filament reinforced with continuous carbon fiber, and they're able to exploit the true composite materials, which would have taken them months to get if they pursued it traditionally. 15% is big. It means that the aircrafts have higher uptime, spend less time coming back down onto ground and refueling, and then going back up to have their surveillance and protection. So this is a massive improvement. It gives them the competitive advantage against their competitors. And then lastly, cost effectiveness. Again, lesser important than 1 and 2, but still something that is evaluated and something that you're trying to optimize for. By bringing the process in-house and utilizing 3D printing, which has very reduced amount of tools involved in the manufacturing, they're able to realize a 25% cost savings by eliminating the tools and eliminating the outsourced vendors that they used to leverage to make these types of components. These three elements together are afforded because of the FX20, because they have the materials that are strong enough to go into flight, because the materials have temperature resistance to withstand in these extreme environments. You empower your engineers to give them the tools they need to achieve optimized results. And this is what's really exciting about the FX20 and why I'm very optimistic that the future is very bright for a continuous improvement of the amount of composites that go into end-use aircraft components. So I'll be passing it back off and looking forward to seeing the questions that everyone asks.
Real quick, I just want to recap on some of the FX20's technical features. The FX20's build volume is 525 millimeters by 400 millimeters by 400 millimeters, or 20.6 inches by 15.7 inches by 15.7 inches. It's capable of reaching up to 200 degrees Celsius using multi-zone heating plus carefully tuned airflow patterns, which help it achieve high thermal uniformity, which is important for strong and consistent part properties, especially when printing with ULTEM 9085. When printing is complete, part removal is super easy with a removable print sheet that's held in place during printing by a precision ground aluminum vacuum bed. Kick off prints with ease with automated bed leveling and nozzle offset calibration. Now moving to the all-new modular print head. The FX20 has 3 nozzles, each associated with a standalone print module. 2 of these modules are for plastic, like Onyx ULTEM 9085 filament, support for ULTEM filament, and 1 is for continuous fiber reinforcement, all constructed with premium materials for maximum performance and uptime. And for all those afflicted by fiber nozzle drag, you'll be happy to know that all of these automatically retract when not in use. An all-new motion system. This design was precision engineered for performance, using a stiff gantry to strong servo motors, micron precision sensors, even to the file format used to control it. The result is a system that blends speed and accuracy for incredible quality parts. The FX20 also has a 7-inch touchscreen, allowing you to connect to the digital forge to start builds, monitor machine status, and perform maintenance all in one place. The FX20 also has an advanced onboard material cabinet for storage of 4 XL 3200 cc spools with precise humidity controls. These spools are 4 times the material as a standard 800 cc spool of filament.